going on? Wow, that's kind of bright, isn't it? Alright, so let me show you what I got out here. Alright, there's my brother.
What's up, y'all?
So what I did here to kind of monopole this thing is put some steel strips, magnetized, right around this whole thing. So now, in between, there's no north anymore, right? So it's monopoled. Oh, there it goes. In between, oh, there it is, right there. That's weird. Maybe the battery's dying in the device. But anyway, um, what I've got here is a north face, south face, north, south. So it comes in north, south. All these are south facing, and pretty much you get a north magnetic field where they're touching. Or I mean a south, my fault. It's all south. It's all blue, it's all south. You get close to the magnet, you got your north field. But in between, it's all south. Up until you get really close. There it is. But like you just move out just a little bit and that north goes away. But it's definitely still there. Just up really close within, 10 millimeters. Like a Hall effect proximity. So this one over here is doing the same thing. It's got north on this side, south on this side. So it takes that south. All these are south out. All these magnets on here, I put the steel strips to try to like link them together more. Like link the south, make it go all the way around pretty much without the. And like out here, you can see that it's like stably south. Move it in closer, and it starts pulsing because the magnets. And then you move it in even closer, you got your north that starts pulsing. It's a magnetic device. It's a nothing really. Well, it's been moving for quite a while now at this speed. So I don't know exactly. Still trying to figure that out. But what I did is I yoked basically with magnetic material all the south facing magnets so that maybe that material is all south now, but it's not. Maybe along the ribbon it is. There's a lot of south energy there. But with momentum, the momentum that I put into it, it's extended now. Every time a magnet passes one of these big magnets out here, it is pulled in a V-gate formation, pulled and then pushed. Here it's pulled and then pushed. So that's how it works. You gotta move it though, it won't move on its own. It's a 14-inch rotor with 12 neodymium magnets on it. Alright, we're gonna go into the other room, check out some motors real quick. Alright, hey, what's up? Alright, we got our 369. So why I call it the 369 or A369 design is you got three 16 gauge coils, you got three 20 gauge coils, and altogether you have 6 coils and 9 magnets on the rotor. So let's check this out real fast. And we got a pickup coil that we can add or take away. It's all hooked up. Let's check out how well this thing gens. We'll put 7 volts in to start. Let that warm up for a few seconds. This is the battery. Okay. 1209 is what we're going to call it. 12.09. But, you know, we're only putting 7 volts in, so we're not going to be getting much out currently. But I'm gonna turn it up to 12 once we get going here. Okay, thank you. So once we get it up to 12, it slows down. Even at 10, it starts slowing down, but the charging goes up. Okay, so we're going to turn it up to its 12 volt system. And it simmers down like a lot. You can hear it. But the charging was at 12.09, right? 1, 2, 3, 4, 5. So I'm going to turn it down now to 10. And it'll start picking up again. But it won't charge as fast. But I think I should leave it on for a little bit so the charge will stick for a little bit. Because if I just run it for, 10 minutes, it's gonna shut off. Or when I shut it off, it's gonna go right back down to where it started at. It'll like... I'm just charging a battery right now. Boom. Alright. Let's move the pickup coil in. That's pretty good. Nice air gap there. Now, bam. Sorry, I can't respond to like vague questions. What do you want to know? I'll explain the whole thing and how it works. Is that good? Alright, so all these coils here are linked in series. Okay, right here is the transistor, which is how it's hooked up. Um, you got 26 gauge trigger coil and 16 gauge coils here. I should turn it off while I try to explain this. Um, so all these coils here are in series. Okay, this set of three 16 gauge. There's about 300 turns in each one of these coils, 220, something like that. And then there's a trigger strand in here of 26 gauge. So you move the coil in a little bit and it'll trigger. Um, the electromagnet is pulsed from the triggering. Okay, it's through this. Every time the magnet passes this coil, it'll trigger um, the transistor to close, which will complete the circuit, basically. And all the coils will get lit up. And when they get lit up, it'll push the motor. Okay, so you got your 16 gauge coils, and then you got 20 gauge coils, which is 2 layers of 20 gauge on soft iron cores. Those coils over there have an extremely potent, powerful magnetic field. It's not very big though. It's just when I put the green paper on top of it, it's like white. Okay, it's very powerful, and that's, I believe, one of the reasons why the rotor goes as fast as it does when I get the trigger coil in the right position. You notice that when I moved it over here just a little bit like that, it started going a lot faster. But it's good to be able to move it. Being able to move it is important in this instance because you got to move it back once you get it in the right position. So it's got to be able to move in and out and then side to side. Thank you. Thank you. Really appreciate that. Now this pickup coil here is pretty cool. Right now it's depicting the amount of ohms. There's 765 ohms, give or take. And when you divide that in two, it's 382 ohms, give or take. So there's double the resistance needed in this pickup coil. And I got 4 strands in there, but somehow one of the strands got caught up. It was a 38 gauge strand. So I got 3 32 gauge strands linked in series, and then I've got a 38 gauge strand, which is right here. And I don't know what to do with it. But if I cut it, that would probably be the best idea, or like melt it and then yeah, get a connection right in the middle of that. Um, it won't be a full connection, but it'll add a little bit of length on, which will increase the amount of voltage generated. I've gotten almost 200 volts of AC electricity off of this coil and this rotor. I think that's awesome. PLA. Iron. No, it's not iron infused. It's just regular PLA. And we do still have 12.12 volts in the battery still. And we only had it running for like 4 minutes. But we got this one with the 6 coils, and we got this one over here. It's got 1 coil of, it's a trifilar coil. So it's got 18 and 20 gauge. We're already generating 103 volts. 108, 111. Look at that. Just climb, dude. That's pretty awesome. Now see that sound is this 20 gauge coils. It's got like 4 times the amount of core material. And then the piezo's, these little discs down here, they're buzzing. All right. So, I mean, finding the true effective voltage for this system, for charging, you got to turn it up. You have to turn it up to 12. If you're going to charge a 12 volt battery, you're better off putting 12 volts in. Um, that's just one thing. And then, wow, I got to take it easy real quick. I know that the system should be balanced, and if it's not balanced, you'll know right away. Because I was just running it for a few minutes and it didn't go up at all because it was at 7 volts instead of 12. But it goes a lot faster at a lower voltage. I mean, it goes tremendously fast. I think 5 volts might actually be its true effective voltage rate. Because this coil will get up to like 205 volts. No, no. No, I just try to give the best explanation that I can. Uh, do I dedicate my life to it? Nah, nah, I got. I'd say I put a lot of effort in, but I mean, anybody that wants to do anything well has to put effort in. Um, and I wouldn't say that I necessarily do it well. I have a very rudimentary style that it fits me very well. There are probably, I know for a fact, people out there that can make it nice and tight, like real nice package, nice and tight, and that's good. And I appreciate that. I watch that stuff and I give it a like. This fits my hands. My hands, they shake a lot. You know, the size is good for me. I'm like 6'3", and tiny things don't work with me anymore. I mean, I used to be able to do the fine motor really good, but I can't do it anymore. So it's bigger now. Look at that. You know, I asked, I'm like, when I painted it, I have no idea what it was, or you know what it was supposed to be. I was like, it's an eclipse, and a friend of mine was like, no, that's not an eclipse. um, but it could be like a star, or you know, something radiant. Definitely could be a combination of radiant light and reflective light representation. Now that I think of it, what was going through my head is like harvesting, when people harvest light, like for energy, and transform it into a usable energy type, like AC or DC. It's like a solar panel, something like that. Um, that solar panel should be able to harvest not just, sunlight, but all light. And they can. A lot of them can, but I'm telling you, like, to a degree where you can harvest moonlight, reflective light. Um, that would be awesome. That would be truly awesome. Then you wouldn't have to worry about any of it except, rain and clouds and whatever. For that instance, but then, you just make a lightning gathering device, hook it up to the same thing. If it's just chilling there making electricity, then yeah, man, you hook it up so when it's raining outside, it shocks the crap out of that thing and produces energy when it's raining too. That's what you do. It's like there's gonna be no reason in the future. Like there's tons of reasons now why things can't happen, but I think a lot of that's gonna be melted away, and I think that companies that can do these things are going to be judged on a lot more than just their bottom line, because the bottom line is going to change. It might change for the worse, but it depends. It's really going to be dependent on what's going on. Um, and then there's like the abundance theory, which I find to be very interesting, where the marginal cost of making things is so low that everybody gets a free one, like a house and a car, or like a passport to robo-taxi, or whatever it is. You get a free this and a free that just for being a citizen of this planet eventually. That would be great. That would be awesome. And do I know if that's going to happen? I don't know if it's going to boil down exactly like that, but I do think there's going to be an attempt in the near future, um, to eradicate certain problems like homelessness. They're gonna end up having better cribs than I have, and that's cool, man. That's cool. In my mind, that's good. um, I'm happy with what I have. All right, so we got the 8 mag rotor over here, and it's spoked. It's got spokes on it, and it's got the 18 gauge wire and the 20 gauge wire in series, and then it's got a 32 gauge trigger. And it's on like this transistor right here. It's a Toshiba. And I'll turn that one on to like 9 real quick, just so we can get a glimpse at it. Nice breeze. Thanks, Hunter. Yeah, man. Definitely chose one hole to jump down, and it has led this far so far. Um, yeah, I would agree with you. I've come quite a ways. but and without changing my style too much, you know. I I would consider it definitely a Papa Bale thing, the way I do it with all the clips and the wires and everything, but it all works out in the end. You know, if I ever learn how to solder, it'll look different. But it's like I went through a whole starter roll of solder and I couldn't even get one connection down, so I'm like frustrated with that. And I think it's because I don't have a good clamping system to hold everything in place. Mm. All right, so yeah, we're gonna head out here real quick, and we're gonna see. Oh, it's still moving in the same direction. That's so cool. But it's going really slow. Let's see if we move this plate in, if we can get it to go any any harder. You know, I think we might have to move it out or pump it in and out. I mean, that would work, I think, if we pumped it in and out, but I'm not going to do that. There we go. Let's move it back out where it was. And it's going to stop in a little bit. But yeah, it's a momentum extendum is what I call it. So it's like an extension of your momentum. And I'll show you how much I'm going to put in, okay? How much momentum I'm going to put in this thing. That's it right there. That's all it needs. And that'll go until I'm done. Heck yeah, man. That's sweet. Now, the Utron. Let me talk about that for a minute. While we charge up the battery real quick. One, two, three, four. 1, 2, 3, 4. There we go. All right, so the Utron, I gotta print 2 new halves that is going to be able to hold this rotor in the middle of it. Okay, so there's 4 permanent mags on there, in here, inside of this, and there'll be 4 inside of the new ones, but there'll be room for that in the middle of that. So it's going to be a kind of rotating device. Um, Self-contained, but it has to be on the shaft, so it's not like you can take it somewhere with you unless you can set that shaft up. So, but yeah, it'll be awesome. Oh, look at that. It's charging like a magic trick, dude. That's awesome. Yeah, this rotor's been around for ages. I bought it for this. purposefully just for this. So I've only made rotors. I made stands for coils. I made bobbins. Um, Let me think. What else could I have made? That's pretty much it. You know, different style, different shapes. Um, but the bobbins and the rotor are pretty much what I've used the printer for. Haven't seen any other reason to use it or have any skills really. I just use Tinkercad. I built this table, if you can't tell. Haha. um, yeah, so I mean, that's where all the quarter-inch stuff comes from. It's like the poles, the pegboard, the bearings. It all kind of goes together to make what I got here. And it all kind of was like a circle, like a cycle almost. It all fits together. It's all the way it is because of, the board and the shaft and the bearings, and it all just came together. But the having the pegboard gave some direction. Um, I used to like I made these levitation discs, like big toroid, just a plastic disc like this, and then put bar magnets around the edge, and I would make toroid, big toroids, or specially sized toroid magnets. Um, and I would like experiment with gluing the magnets on in different formations and cross formations and having multiple discs and seeing if putting pressure on the top and putting pressure on the bottom would make it levitate better or worse, all that stuff. And I found that having pressure on both sides works okay, but it adds more friction. It's a thing, man. So it won't spin for as long, but it'll probably be more stable than, say, if you just had it floating there. But like I was saying earlier, this coil right here has got 764 ohms when the rotor isn't moving. So, and you divide that in half, it's like 382 ohms times 2. So that's pretty neat. Um, yeah, it's pretty close. All right, so I might have been a little off with that momentum extending, but we're gonna check it out. Still moving and about the same speed. Let's check it out. It's a little slower, but I just nudged it, literally. And I think having those strips on there really affects the magnetic field to a point where it's kind of, what do you call it? Just, there's no gap, really, but there is a gap. There's literally gaps in the steel plating, but I think it links at least 3 magnets together, each strip. Awesome. So I put forth the proposition earlier that this painting could have been uh, an experiment that's going on today. An RAV, I think it's called like a radiant arc vortex. And when I saw it, I was like, damn, That looks really kind of like what I did. And that might be an explanation for what it is. Because, you know, I'm like, it's an eclipse, but it's not an eclipse. It's something else. He's like, that's not an eclipse. I was like, yeah, man, you're probably right. I don't know what it is. And now maybe I do. And that was 4 years ago. See, you gotta hear when you hear those piezo's clicking. That's when you know you got a good connection with your trigger coil. It's 104 volts, 111, 120, 140. Woo! 150. It's amazing. I want to let it rip, man, but I have a feeling that there's going to be something that happens that I'm not going to like. I have to put more tape on it to feel good about that. My kids are home. Sweet. All right. Just love how that energy tapers off. So what I think I can do with the energy from this pickup coil is run one of my paperclip switches to run another wheel, maybe the big wheel that's out there. The thing is, it's got to be done through like a paperclip switch. I don't. Well, maybe if we funnel it through this, all the energy off the pickup coil, and put it through that, and we hook that up to a transistor to run the other wheel. So we're gonna run it with the energy off of this thing, this cat bank down here. It gets really choppy when it slows down because those coils in the back are like straight up core material and they're right up on there, pretty much. So it's better for me to stop it. All right. Yeah, that's going to be definitely an experiment for a later live stream. I'll have that all set up with the second wheel on a transistor. That would be great. And then it would be able to go at a speed that's, well, I mean, I can get the paperclip switch going pretty fast. Actually, man, that could be really good, especially the big wheel, man. I got that going really good. But yeah, I can't do it on that wheel. But you get the magnet, the paperclip right up on there, and it'll knock on that copper, just like a reed switch. Oh. So that'll be interesting. See if I can run a transistor, because it roughly, I would say it's going to cost more per closing of the circuit with the transistor than it will with the paperclip. Because I can turn the paper clip all the way up to 12 volts and it doesn't draw 50 milliamps, not even. But I'm thinking it's going to do like 300 with the transistor. And it's going to do it fast. I don't know if it's this coil is producing energy like that. We'll have to find out. All right. All right, so yeah, I want to put forth a question. These bobbins on this rotor, it all happens to fit really, really well together. But I need to know what gauge wire I'm going to be putting in here. So I was thinking 20 and 32, make them all bifilers like that size. See, I got the 20 gauge. I do have a degree, actually. That's my name, don't wear it out. Oy, oy, oy. Oh man, I think that we'll either make it 20 and 32 or 20 and 26. This is 26 right here. And all these rest of these are 32. Or we could make it 32 and 32. That would be awesome. But honestly, the 32 gauge is going to be the one that weighs the most if we fill it out all the way. So it might end up being 32. Just all 32. Maybe not even doubling up the 32s, but making it all one strand of 32. And then linking them in series. And I'm looking to get the biggest, no core material. We're not looking to generate. This isn't for generation of any kind. The Utron that I'm building, I'm not going to be generating with it. What I'm going to be doing is I'm going to turn it into a counter-rotating device. And it should be able to it's going to be self-contained, so all I have to do is spin it, and the mechanism inside should, perpetuate that spinning motion as long as there's juice in the batteries. You can't really see it, but the shaft is a little bent. It's a little bent. And I didn't notice it until after I, shafted the rotor. So that sucks. But, yeah, that's what's going on there. Ow. Oh, dude, yeah, that was good. Awesome. So this thing over here, man, it spins very well. It has very good bearings on it. Hybrid bearings. And with it being able to spin like that, with just, you know, me spinning it, having the rotor on in the inside. Here, let me try and get this off. All right, so we got 3 big neos in there. And then we're going to hollow out the rest of this and get the rotor. Fits in there really good. I had a magnet chilling on the top there. And I've hooked this up just to see if it would fit. And it's like perfect. Look at how close the clearance is. That'll spin nice in there. It'll have the torque it needs, everything, being that close. Oh, wow, man. And it all fit together like magic. And as soon as I get the right, I think I only got one chance at this, honestly. So we're gonna hollow it down about 1.5 inches, and then we're gonna hollow out the center, the size of the magnet, and we're gonna put the magnet in the hole, and we're gonna rest the rotor in there, and then we're gonna hollow out the other side. We're gonna print 2 new ones with the hollowness. And then that rotor should fit right in there. And bachelor's in business administration with a major in accounting. What you got, man? Oh yeah, man. We're going to be starting our new segment later on this week. So please, I'm encouraging all ye trolls to participate. We're calling it the Trollanoxtopy. And yeah, we're gonna we're gonna perform the medical procedure ourselves. The Trollanoxtopy.
With some dialogue and bits.
This is going to be based on your comments solely. So bring them in. You know anybody that wants to troll? Bring them on in, because we're going to make a public example of them. Yes. That's what the whole skit's about. It's like, you know, we're going to make fun of it.
You gotta make up a word for it.
I can't really make up a word. Maybe.
It's funny.
It's a little pulse motor. And I know my heart like has a capacity to be a troll sometimes. I mean, normally I'm really not a troll. Like if I drop shade on something that you're doing, I will tell you why I'm doing it. So that literally takes me out of the realm of being a troll. But I understand that urge to say, hey man, don't waste my time, yada yada yada. I want my time back. That's the one I've heard before. I want my 15 seconds back. Sorry, pal. That's kind of the dumbest thing I've ever heard. And it just after hearing it so many times, it's like, can you? I mean, if you're gonna do it, can you be original about it? Sick it, hearing the same thing over and over and over again because it's not right. Yeah, we crossed some sort of threshold right there. Amen. I just cut the power. That's what happened there. But I heard my ears start ringing there. Awesome. So, yeah, I think that as long as you wrap the coils correctly, as uniform as possible, having more core material than copper is actually a really good thing for power. I would advise doing more than one of those coils though, like having a series set of those coils like I do right here. Because pumping anything through that is probably going to blow up whatever you have. Um, so you need more copper, honestly, to make it work better. But each one of those, I mean, I'm telling you, man, that the acute strength of those electromagnets are beyond anything else that I have. No, sir, I don't believe in that. I do not believe in the word free, honestly. This is not a free energy device. It can charge a battery. That much I do know. It can charge a battery. It can run another pulse motor. But as for having more come out than is put in, I can't even make that happen with a pickup coil. It doesn't really happen. Not in a usable way. Not in a way that you can like turn it back onto the same wheel. Like if you're putting it into a different mechanism, it'll work fine. The minute you try and turn it all back into your same thing is when you got problems. Yeah, I don't believe in any of that stuff, man. I literally only believe in what I can do. I can make this wheel move pretty fast, and I believe that the electromagnetism coming out of those coils in the back there is stronger than anything I've ever done. But even with that, it costs, it's not free. I mean, my paperclip switch over here is tremendously efficient, but it's not free. Um, I can put it all the way up to 12 on this power supply right here, and it'll still read zeros across the board for the amperage. And it doesn't mean 0 amps. What it means is less than 100 milliamps, which is very good. Um, if you got less than 100 milliamps, you're doing it right.
There's a poll.
Okay.
Um, if you would buy a 3D printed rotor online, would you want to buy it from stock inventory or submit your own design?
Oh, okay.
So that's what that recent comment is.
Okay. Yeah. I I'd do my own. I mean, I would like a stock rotor to mess around with, like maybe a milled one or something like that. But I'm happy with building my own. Um, but yeah, I'm limited by PLA itself. It's very versatile, but like the generation capabilities of this rotor would be way more if it was pure aluminum. Just saying. Way more. No, I agree that it's not about how much you generate, though. It's about how much you put in. It really is. It's always going to be like that. Um, yeah, man, I've gotten higher numbers on the other side, but it's not about those numbers. At least that's what I've been led to believe, that it's not about those numbers. It's more about the cost it took to get those numbers. Even if it's very minuscule, it just means that it's more efficient. And I don't know. I put forth another proposition that if you put a penny into a machine and it gives you $100 back, does it make it make it both more valuable penny, but a less valuable $100? I agree. I agree, man. And I'm totally saying I've gotten insane numbers before. I've gotten up to 500 AC volts off of 2 pickup coils. All that, you know, and just off of something like this little coil right here, 500, dude. Like, yeah, it's not small fries. I've actually been shocked by something like that before, and it's interesting feeling getting shocked by one of these things. But I honestly feel like in order to get that zap, you're gonna have to get the BEMF directly into your. I don't even know what it was that shocked me, but I was definitely trying to hook up a back electric motor force connection. I don't understand what you're. I don't understand what the aggressiveness is all about. Let's tone it back now, man. It's like God grief. All this con- uh, generation power coming off of this 369 design is actually coming right through the Bedini extension. That's what I call it. It's a extension from the collector. Goes straight from the collector. It's actually going through this cap bank and then into the battery. So, and it charges this battery 100th like every 3.5 seconds. So it's good. And that's a battery. This is a 12 volt, 20 amp hour, 20-hour battery. So it's not a deep cycle battery. I don't have that kind of money. Maybe when they're free, I'll get one. Mm. No, it is on the list though to get a deep cycle battery. I just needed to get the two, and it were a good price, like 47 bucks for two. So, yeah, that's where I went with that. And they've done good for me so far, no problems. They charge when I want them to charge. Yeah, like I said, man, I don't like that aggressive behavior. It really kind of rubs me, and it's because that I have a truly aggressive side, and I don't like that being provoked by any kind of, yeah, attitude problems. So that's what we're narrowing it down to. We're trying to keep it like within an hour, about an hour long. So I really appreciate everybody coming out tonight. Let me flip this real quick. Yeah, I really appreciate everybody coming out tonight and being cool. Um, yeah, so everybody that has, something negative to say, please in the comments. You will be, all right. But everybody else, man, have a great night. Please subscribe. Bye now.